Let us solve this problem in a super simple way, which is very big problem actually. It's having a massive following with much more information to be given here so that you can understand these matchings here. Let us see what is going to happen now. You all know current is nothing but rate of flow of charge, where Q is nothing but N into E, number of electrons and charge on the electron. Okay, so this is the formula here. But here, if you see this conductor and it is connected to the battery, let us imagine this is a conductor having length L, which is nothing but drift velocity into time t. Okay, because displacement is nothing but velocity into time here, length is also written as velocity into time here. So therefore, here in this let us imagine there are number of electrons present in this small wire in which potential difference is applied here. Let us see what's going to happen now. So current I is nothing but N. What is N here actually? N is nothing but number of electrons in volume V. So this is the wire having volume V here. So how many number of electrons are present in the total volume of this wire whose cross section area is considered to be A here? So therefore number of electrons is N, volume is nothing but area into length here, therefore number of electrons is nothing but area into length. Here length is nothing but drift velocity into time here. So according to our formula, you should know that N E by T is our formula. In the place of N, you have to write NA Vd into T into E divided by T. So Tt gets cancelled. I is nothing but NEA Vd. This is the formula for current here. Okay. So once you get the formula for current, then what is the formula for current density? First, let us start from the last. What is the formula for current density? See, current density is nothing but current passing per unit area. Current density is nothing but current passing per unit area. Therefore, which can be taken as NEA Vd divided by A. So A gets cancelled. Therefore, J is nothing but NEVD. Okay. So J is nothing but NEVD. So the fourth, that is current density formula, is NEVD. Now, let us discuss about what is the meaning of relaxation period, or first we shall go for drift velocity. What is the meaning of drift velocity? This is said to be the drift velocity here, but let me discuss what is going to happen here. So you all know that let us consider one electron which is in between one positive and one negative terminal. You should know that this electron force is applied, which is making the electron to move in an electric field from negative to positive. Okay, so here let us imagine the initial velocity you will find out here. You should know that V is equal to U plus AT according to equations of motion. Initial velocity is 0, V is equal to A into T here. Okay, A into T here. So this is going to be the distance traveled here, and the time taken to travel from here to here is said to be tau, which is taken as relaxation time between the two collisions. Let us imagine what is going to happen. I told you that force F acting on the electron is taken as E into capital E, where force can be taken as MA, which is equal to E into capital E. Because force is given by Q into E electron according to electrostatics, but charge on a single electron can be taken as Q is equal to N into E, which is Q is equal to E because N equal to 1 here. Because single electron we are considering, so N equal to 1. So then let us see what is going to happen here. Acceleration is going to be E into capital E by M. Therefore, the drift velocity can be taken as, this is drift velocity. That means electron has been drifted, moved from one place to another place. A is considered to be E into capital E by M, and T is taken as relaxation time, that is tau here. So we got the formula for drift velocity, and the formula for drift velocity is this one, E into capital E by M into tau. Therefore, drift velocity formula is going to be this one. Okay. Then what is electrical resistivity here? So B, electrical resistivity. We shall discuss about what is electrical resistivity here. So for that, electrical resistivity you have to find out here. So first of all, we know that I is equal to NEA Vd. And just so we got the drift velocity, another formula for drift velocity is nothing but E into capital E by M into tau here. Okay. So you can just substitute this formula here, N into E into A, and with drift velocity is nothing but E into capital E by M into tau here. So therefore the current formula is NE square A E by M into tau. So you should know that electric field intensity is nothing but electric potential divided by length L. Electric field intensity is nothing but electric potential by length. Then if you substitute here, you are getting how much? NE square A tau by M. Instead of E, we will write V by L. Okay, then I can write this as I is equal to V divided by this ml I am writing in the denominator, and this total value I am writing in the denominator, that is N E square A into tau here. Okay, so it is just like V by R. I is equal to V by R, which is said to be Ohm's law here, because V is equal to IR. So just now I got what is the formula here? The new formula for resistance. In the place of resistance, what is present here? So resistance is nothing but M into L by N square A into tau here. Okay. From this, R is equal to, we can write M N E square tau L by A. Okay. So you all know resistance is nothing but rho L by A. Okay. So what is the formula for rho? See, rho is said to be resistivity, which can be written as M by N E square tau here. Okay. So from this, what are we going to get now? What are we going to get now? So he's asking us to find out electrical resistivity. Okay. So electrical resistivity is M by N E square tau. M by N E square tau. M by N E square tau is the electrical resistivity. But relaxation period he is asking. We can take the relaxation period as this one. How? Let us see. Okay. So we got this one. So we can take relaxation period as tau, which can be written as M by N E square rho. Okay. So relaxation time is nothing but M by N E square rho. M by N E square rho. So 3 are over. Then the final thing is you have to find out what is this electrical resistivity, which is E by J. You have to find out. That's it. So electrical resistivity is nothing but E by J. How are we going to find out that one? Let us see here now. First of all, you should know that current density is nothing but I by A. Current passing per unit area. And you should know that I just now we got. What is the value of I we got? This is the value for I we got now. Yes. This is going to be the value for I. I is equal to NEA VD divided by A gets cancelled. So J is nothing but NE VD, but just now we got VD is nothing but E into capital E by M into tau here. Okay. So this if you substitute here, current density is nothing but NE VD is nothing but E into E by M into tau here. Okay. So this can be taken as NE square E by M into tau. Okay. So what I am going to get now, let us see here. From this it is understood that J is nothing but NE square tau by M into E. Okay. So what is this going to be? This is said to be sigma, which is called as conductivity. R, which can also be taken as, this completely we can write it as E by M divided by N E square and tau. Okay. So this can be taken as E by rho. Resistivity. Okay. So what is the formula for resistivity? Let us see. What is our problem actually? Electrical resistivity is taken as E by J. We have to prove that electrical resistivity is nothing but E by J. So therefore, as J is equal to E by rho, rho can be taken as E by J. That's it. So your 4 options are being proved here. Thank you very much.